All right. So actually, this is kind of a nice segue from the last presentation and Chetan's. I think it was Chetan who asked the question, like, what happens after a proposal is accepted? Does the feedback process stop? And I think, at least in the case of this project, no, it does not stop. And so this is a presentation about a project that did go through the proposal process, but it's still in its very, very early stages. So the overall thrust of this project is to make the Mozilla data platform more comprehensible to people outside of data engineering. But just a warning, this presentation is going to be a little rough. Both the project and the ideas behind it are still in a very early stage. And the intended takeaway is that I want your feedback and contributions. So I'm just going to start with the sort of like a really quick overview of the data platform, which is probably going to be familiar to people, but it's sort of this is sort of the scaffolding off of which this presentation sort of is going to lie off of. So it's kind of at the lowest level, right? In terms of like data, we have what are called client-side applications. So that could be Firefox, or more recently, it's projects using the Glean SDK, like Firefox for Android or Lockwise or like whatever. And then these applications, they submit telemetry to our data in a specific form, to our servers, and then that's ingested, using a set of software which we call GCP ingestion. Then that finds its way into raw ping tables in BigQuery. In some cases, that's sort of enough, to start doing analysis or visualizations. So, you might be looking at raw ping tables using STMO or the Glean aggregates dashboard or GUD or whatever. Or, in some cases, the raw ping data is just too raw. And then we have what are called derived data sets, which, attempt to aggregate, this data in useful ways such that it can, then be analyzed via STMO or like a data tool of some kind. But let's talk about this system for a minute, right? It's highly complex, right? Like it almost doesn't need to be said, right? So it's hundreds of thousands of lines of code at every level, written in many different languages. The Glean SDK is Rust or with Kotlin bindings. GCP ingestion is written in Java. Higher level pieces like BigQuery ETL are written in Python, and then there's SQL and so many other things, right? So much complexity. And really, I think up to now, the goal of the data platform, from data engineering's perspective, its primary goal is just to make things work, right? We're just trying to gather and process data faithfully as it was sent by clients, and making it comprehensible to the rest of the organization. I think it's always been something we've been worried about, but up to now, it's been more of a secondary sort of consideration. So, I think, when you have a system like this complex, there's just a lot of details, right? And these details often really matter when doing the analysis, right? Like how, something, the way something is defined on the client and how it gets sent to our servers, that can have a huge impact on what data we're getting and then and thus, the results of your analysis. But the question is where do you get those details? Do you just spelunk through every GitHub source repository that make up the data platform? It's probably not reasonable, right? So I think, I think we have recognized that there's need for tooling, to sort of make these details, expose these details to people in sort of a digestible way. And so I'm just going to walk through very, very quickly, some of the tools that we've sort of built so far, just to sort of get a flavor for what, the types of, angles of attack that, I think I'm hoping to provide with the Glean Dictionary. So, I guess, the first, there's the well-loved probe dictionary, right? So that renders a representation of what we're collecting at a low level versus Firefox. Firefox engineers, they define probes, with a specific format. And then, once that's defined, they're allowed to submit data to our servers. And then, this tool, basically just tries to render faithfully what the engineer defined, and then tries to provide some sort of helpful links to other, resources to help people analyze things, right? So but I'd say that's pretty limited in scope. And like you can sort of see right here that it's out of date, right? So there's a link to main summary, for this probe, which is, we don't recommend that people use main summary anymore. There's a link to the measurements dashboard, which I guess is just on the edge of being completely out of date. It's about to be replaced with GLAM. So it's, I think we've had some trouble keeping this tool up to date, and it's kind of limited in scope. The next thing to talk about would probably be docs.telemetry.mozilla.org, which is a project I've been putting a lot of love into over this year. And in some ways, the Glean Dictionary is sort of an outgrowth of that work. It attempts to, docs.tmo attempts mainly to document both the higher level parts of our pipeline, so things like derived data sets or analysis tools, as well as give advice on how to access lower level pieces, like the pings. It's manually maintained and curated. It's just basically a bunch of markdown documents, which gives you some nice flexibility in terms of like how to explain things. But I think, for stuff that's kind of has a machine representation, it's basically perpetually out of date. Like, here I'm showing a view of the search aggregates data set, very much used, by data science and others, to understand our revenue and other important business questions. There's a schema definition here, and I guarantee you that it's out of date, right? Because it's just, we can try to have processes and encourage people to update the docs when they update a data set definition, but in practice, I found that like things just always fall through the cracks, no matter how hard you try. If the representation of the data model lives in a separate place from the documentation. And then sort of like the last one I'm going to go through quickly is like the Google's data catalog, or I mean, equivalently, the schema browser and the BigQuery console. And this, provides sort of a view of how things are laid out in BigQuery, which is really useful if you're writing an SQL query or something like that. And it does, so some of our lower level metadata data does make its way there, like column descriptions, but it doesn't, like a tool like this is inherently not really going to draw links between the BigQuery representation and basically our data model, right? Because it's intended as a generic, view for Google's customers of BigQuery. So like they're, like we have a particular use case and a particular data model, say an oil and gas firm that's using GCP has a completely different one. This is not, and BigQuery, a BigQuery based tool is always just going to only be able to show things from BigQuery's perspective. So useful, but like limited, right? So here's the proposition behind the Glean Dictionary. So what if we had a tool that gave you a holistic view of the outputs of every part of the pipeline? So like I'm talking about everything, right? Like not just we've defined on the client, but like also the derived data sets, the details of how the data is processed, how data ends up in BigQuery, and then also showed you the connections between them, right? Not just showing the pieces in isolation, but providing links between these pieces of the pipeline. So, if you're looking at a derived data set and you have a question about how it was created, it's easy to go back to the raw ping level, to see how that data was initially created. And, keep it always up to date, right? Like whenever, we update the schemas on the low level or a data set definition, keep this tool up to date. And then finally, like I think a big consideration, and this sort of ties into what I was talking about with the probe dictionary, which is actually pretty hard to work on in my experience, is that we want this to be super hackable and extensible. Like it shouldn't be, you shouldn't have to wear a data engineering hat or be a front-end JavaScript expert to like work on this. So that's kind of the premise of this project. And I think maybe like probably I think I'm just going to go super concrete for a sec and just give a quick demo of the Glean dictionaries just to sort of give people an idea of sort of some of these ideas in action. So I'm just going to quickly stop sharing. And I'm going to reshare. Okay, so this is the Glean Dictionary in its current super rough form, but there's already some of the ideas that I want to present here. So first of all, you'll notice that it has this show deprecated applications checkbox on the top. And you can check it if you really want to see old and broken stuff that we don't care about anymore. So like it's very opinionated about what we want to show and what we don't want to show. So that's kind of the first item. And then you can go in and see more detail about a particular application. And like this is sort of the stuff domain of the probe dictionary or that sort of type of tool. It's just showing client-side type data. But if you click through to like a particular ping, you can see that there's this not great looking link right here that takes you through to what the actual representation looks like on the BigQuery level. So like there's this clean handoff between like what a data model looks like on the client and like what the data model looks like in terms of what you actually need to access the data. So, like there's this, friendly schema browser with a search box where you can search for stuff. And then there's also, like if somebody links you to this view to answer a question and you have like, you want to know more detail about the metric itself, there's this link back to the metrics page, right? So you can sort of draw those connections. And this is like really, really preliminary, but like, I want to have all the connections in this tool, right? Like, even back to the source code repository, ultimately, if you want the real source of truth on like how a piece of data was generated and collected, right? I mean, and this is all stuff that I think, experts, with years of experience just kind of do implicitly by, we know where to Splunk through GitHub or the Mozilla Mercurial repository, but I want to make this really accessible to everybody, right? And a lot easier. So that's sort of the elevator quick demo pitch. I'm just going to switch back to the presentation. Okay, so here's where we're at. We're at phase one. So the first objective is to just produce something mostly equivalent, maybe a little better than the existing tools, right? So replace the probe dictionary and the schema dictionary for Glean applications only. Glean is the future. We'll keep the old stuff working, but let's put our priority on like where we're going, not where we've been. The architecture is intentionally very, very simplistic to make it easier to hack on and contribute to. So we have some basic ETL written in Python that scrapes our existing probe metadata and generates a static set of data that is amenable to being quickly loaded inside the view that you just saw. And then there's a front end that's written in Svelte, which I think is just wonderful. I'll talk about that more in just a second. And then, so I built this initial scaffolding about a month and a half ago. And then, so I proposed that we do an outreachy project, and we just got through the application process. We're going to select an intern among those who applied today. I think we had like 10 people, of different backgrounds who made one contribution or another to the Glean Dictionary and other projects. Thanks to everyone, by the way, on my team who helped mentor them. But I'm pretty sure none of them had used Svelte before, and they were certainly unfamiliar with the data platform, and they still got like a heck of a lot done in a pretty short period of time. So I think this is like, really good validation of this sort of approach, right? I think if we can make it accessible to those people, I think we can make it accessible to all of data or even all of Mozilla. So like Svelte, like I don't want to spend too much of this time on Svelte evangelism, but I think it's just a really, really great way of writing web applications. Getting up and running with it is really easy. You just need NPM. And I think it's just, the learning curve is so much shallower than React. Like, you just basically need to know a little bit of JavaScript and a bit of HTML, and then like you're just off to the races. And I think, like making small changes or even larger changes is totally within the scope of, I think everybody throughout the data org. So, moving past phase one, I think moving into phase two, and this is sort of where the scope of the outreachy project is, that we're going to extend this to support the derived data sets, using the metadata that we already have in BigQuery ETL, augmented with, like markdown-based documentation, we can put that right in the Glean Dictionary and create those links that I was talking about. And then, taking it even further, we can possibly even link out to, artifacts that are created using those derived data sets, like dashboards or reports or other artifacts, like anything that's published, by us that we can know about that has scrapable metadata, we can like put into this tool and link to it effectively. So yeah, that's kind of, I think, where we'll be going in the outreachy internship. I mean, I think it's going to be a collective effort, like more of a collaboration than like the outreachy intern doing everything. But I'm going to be mentoring, Anthony's going to be mentoring, and maybe you want to help mentor too, right? We really want this person who's coming on to have a good experience. And then sort of just getting close to the end. Like, here's the premise here, right? Like, I think let's just go beyond just making things work, right? So this is an example of a change I made early in the development of the Glean Dictionary. So, to ingest a Glean application, currently there's like a big YAML list of stuff in the probe dictionary, and it just basically had just enough to tell us that, oh yes, we validated that this is a real thing that Mozilla has built, but it contained very little else. And so like this was sort of a pull request that I made very early in the process to add a description field, tell people whether or not it was deprecated, what channel it was on. None of this is necessary for ingestion, but it makes such a huge difference in terms of making the data comprehensible to somebody looking at it. And I think there's so much more that we could do on this sort of level, right? And then not only for making it, useful inside the Glean Dictionary, but maybe inside other tools as well. So like, let's do more of this. And if you have ideas on something that's confusing, even if you don't have it fully formed, like how to change stuff, like let me know. And like, let's talk about like how we can make this system work better for everyone. So yeah, let's join us. So there was a proposal which was accepted, but it's not too late to provide feedback. Like this is a large ongoing project, and we'll be course correcting and modifying as we go along. As of yesterday, there's like now a prototype on Netlify that you can try and run and use and break. And I'd encourage you, like, don't just file issues. I mean, I appreciate issues, but if you see something that's simple to fix, why don't you try your hand at making a pull request? It's actually pretty easy to get up and running. And the intention is for this to be a really easy project for it to hack on, even for people who aren't like data engineering or front end specialists. And yeah, finally, join the conversation. There's a Glean Dictionary channel on Matrix where the outreachy applicants are hanging out. We're trying to kind of work in the open with this project and make it on an ongoing basis, not just for during the application period, but on an ongoing basis, make this sort of an example of the data org working in the open, which I'm really excited about. So yeah, thank you. That's it.